Hello everybody, thank you for coming. This is a session about going into the internals of SUSE Manager and seeing how SUSE Manager implements the features that you use. I suppose most of you are SUSE Manager customers already, they're using SUSE Manager. Can you please raise your hand if you're using SUSE Manager? Basically, well, most of you, okay. I guess others might be interested in the product, that's cool. So, well, that's me. That was me a few years ago. My name is Silvio, and I've been a SUSE Manager developer since about 6 years. More recently, for about 2 years, I've been coordinating a small team of developers, especially around the topics of scalability and performance of the product. So trying to optimize the product in very large installations, that's what I typically do. And I have a passion for software architecture, so that's why I'm very passionate about this particular talk when I get the occasion to explain to you how SUSE Manager works internally. So you will see a lot of diagrams, about how the system works internally. This is my colleague Raul. So you want to introduce yourself, Raul?
Yes, definitely. So my name is Raul Osuna. I have been working with free software for quite a long time, and in the last 6 years working for SUSE. I'm a technical support engineer, mainly focusing as backline support engineer for this product, for SUSE Manager. I also take cases from customers for general SLES or even other products, but in a smaller amount. Usually I have enough work just to focus in SUSE Manager problems.
All right, so Raul and I have been collaborating quite a lot in this last 6 years. We've been together on many bug resolutions at least. And the idea here is to give you a double perspective. So my own perspective as a developer is to show you the architecture and how things are supposed to work. And Raul's perspective is, what if they don't? So how can I troubleshoot my system better knowing how it works internally? So the overall idea of this talk is basically about diagnosis. So how do I find out SUSE Manager is not behaving the way it's supposed to behave? And in particular here we are concentrating on the SUSE Manager server. We want to give you some conceptual tools to do diagnosis better. And for that we take some inspiration from the medical world. So what does the doctor do? What are the tools that the doctors have at their disposal when they need to diagnose a patient, when they want to know what the issue is? Well, a very helpful one is an atlas. So knowledge of the internals of the organism is very precious in order to make the right diagnosis. And this is more or less what we're trying to provide today, right? So this wants to be SUSE Manager Anatomy 101. We are going through it via use cases. So this is something Raul has inspired me to. So I'm not just going to show you the whole architecture of all possible things that one can do in SUSE Manager. We're going to focus on real use cases, so features you actually use probably every day, and we will see how those are implemented one by one for traditional clients, for salt minions. The idea here is I will present each one. There is a moment that's reserved for Q&A at the end of a talk. But in case you have some questions, it's better to stop me or Raul immediately, because everyone will be a very deep dive. So while we're on it, just feel free to stop us at any time. Okay. So I will make extensive use of diagrams to explain the concepts and how SUSE Manager works internally, which is my equivalent of the drawings in an anatomy atlas, And this first few slides will show you how those diagrams look like and what they mean in general, so that we can go through them. It's very quick. Okay. So I am using a particular kind of diagram, which is relatively poorly known, but is very easy to comprehend. So I'm now going through that particular language that I'll be using here. It's called the interpreted pattern nets. This is the easiest symbol. It's a user. Might be you, might be a program that interacts with some other parts of the system. The system is made up of components, which are those boxes up there, and components can exchange information through channels. A circle in the middle represents a communication channel between component 1 and component 2. That means the component 1 can send a message to component 2. And this green symbol is how we represent a message that's flowing from component 1 and component 2. Note that we have arrows here. So in this particular case, component 1 can send a message to component 2, but not the other way around. This is a slightly more complicated example. This is a user interacting with a component that in turn activates another component. So the simulation of the pattern net, that's the name of this animation, just shows the message as it is translated from one channel to the other. Please note that the components are activated by the message when the message goes in. We do have some components that are activated every a certain amount of time. For example, cron or Taskomatic. And this is the way we represent them, through a self-activating component. I hope this doesn't scare anyone so far. So this is another piece. The double arrows here means that the components can just freely exchange messages. In this particular view, we're not really interested in when exactly the component is activated. We just want to say those components can talk to one another freely. And I have a last one here. This is a persistent data store. It could be a database, a file system, or something like that. And the idea here is that messages can go in and stay there without really going out, while all other channels that we've seen so far are temporary, volatile in nature. Okay? So this is all about the visual language that I will use. There is one catch. This is a model. I need to simplify many things in order for it to be accessible. In practice, SUSE Manager is much more complicated in the inside. So I really try to be as accurate as possible, to be as precise as possible. But of course, I'm cutting some corners in order to fit it all on a slide. So please keep in mind this is always a slide simplification. OK, let's now start with the real meat of this talk. Okay, so let's see how package installation works, and in particular on traditional clients. We will assume we will do that through the web UI, just to start with a familiar example. So the pattern net looks like this. We have a user. User interacts with a web browser. The web browser interacts with an Apache 2 server inside of the SUSE Manager server via HTTPS, of course. That in turn will either serve some static files directly from the file system, like images and fonts. More importantly, it will exchange messages with Apache Tomcat, which is another service that's running in your SUSE Manager server, and that contains servlets that really contain the logic of the web UI. So ultimately, messages coming from the user will flow down to servlets. And servlets actually do something active, like writing into the database. When you're scheduling an action, you're basically writing that action into a database. A database that would be a row that says, user 1 wants a package installation on server 1, 2, and 3 of this package set on this particular date and time. Okay. Or at least, this is what should happen. Mm-hmm. So Raul, do you want to talk about what can go wrong in here? And how can one notice that something is wrong? How can one troubleshoot if it happens?
Mm-hmm. Yes, for example, the very beginning was user will interact with a web browser. What if the web browser is not there? It doesn't load. So first thing that we would need to check is the logs for these components that are involved. So the Apache, for example. And in general, there are many services that are involved in SUSE Manager, and sometimes for a new user, it might be difficult to tell which service is not working properly, but SUSE Manager has a meta service that is called Spacewalk service that you can use, and you can check Spacewalk service status, for example, and maybe you can see that the Apache is down, for example. And yes, and like this, you can, if you are not sure which component has a bad functioning, and you can easily check this way. And there are a lot of logs, for example, for Apache, in var log Apache 2 error log, that you would check for Apache, for example, if you see that that service is not working. It is mostly this. In addition to this, there are really, depending on the component, you have a lot of logs to check. Sometimes, not even myself, I don't know the logs by heart. So what support usually asks for is a support config, which has a spacewalk debug inside. It's a tarball with all the logs of SUSE Manager, and it is very handy if you fetch the support config, open the tarball of the spacewalk debug, and you have a structure of all the logs in SUSE Manager, so you can check easier, and you don't have to remember in which path each log was.
So just to make your life a little bit easier, we prepared presenter notes for these slides. They will be available in the website, so you will be able to download a PDF with all of the slides and the comments. And in the comments for each scenario, we listed the log files that you need to check if you suspect that there's a problem in a particular component that's described here. So you don't have to take all the notes now. So we kind of know the logs, but we're not going to list all the file names because, as Raul said, it's very many. And yeah, if you have a doubt, a good strategy, you can use a support config command line tool, and then you have all the logs in one place, which is easier to navigate if you don't know exactly where all of these are. Okay. What if I want to use SpaceCMD? SpaceCMD is a command line tool that allows me to, for example, enter a package installation action directly from the command line without using a browser. How does this picture change? Actually, not much. Only these two items changed. So you're using SpaceCMD instead of a browser, and SpaceCMD still talks to Apache HTTPD, and all the rest is unchanged, but the protocol is different. Instead of using plain HTTPS, SpaceCMD uses XML-RPC inside of HTTPS. But from an architectural point of view, it's very, very similar. And indeed, if you do have a problem, I guess that's more or less the same things that you have to check, right?
Mm-hmm.
So what the error in this case will not be a blank page or a 404. You will have an error in the command line from SpaceCMD, like server is unreachable, or why is it unreachable? Could be that Apache is down, could be that Apache is up, but it has errors in the logs, or Tomcat is down, or the database is down. So that's how you can start troubleshooting, right?
Yes.
Are there more creative ways to break the setup?
For example, we are installing packages. There is a daemon that is called Taskomatic. And for example, if you simply stop that, well, when you want to break it to show it in front of the audience, I would stop Taskomatic, I would send a task, a package install, and it wouldn't happen. Then what is wrong? I would check spacewalk service status, and then I would see, oh, Taskomatic is down. It's not taking task.
It will be clear why Taskomatic is involved in a couple of slides from now. So since this is very common, I'm also using this more compact form. This is just an equivalent of what we have seen so far. It just means there's a user, there's a UI macro component that has Apache and Tomcat and the database inside, just to prove the point. And of course, this is the simulation is pretty easy. And here you can see this mark represents the action that's now scheduled in the database. So now what happens when this action has to be delivered and executed on the traditional client? Let's see that part of a story. This is the network. Imagine a wall here in the middle. This is what happens on the server side, and this is what happens on the client side. So on the client side, you have a daemon which is called RHNSD, which will be activated by default every 4 hours. When it does, it will call a command line tool, which is called mgr check. You could also activate it manually if you want. mgr check will check if any actions are there for this particular client via an XML RPC API that's provided by a Python API server through Apache, basically retrieving this information from the database. And if there's anything to be done, that will be performed. Like a package installation means zipper will be called. Okay. This complicates the slide a little bit. As we can see now, we have the zipper component that's activated by mgr check. And zipper now typically needs to download packages. How does zipper download packages? It does that through a plugin. And the plugin will reuse the same communication channel to fetch the package, always from the same API. So let's try to see how a simulation looks like. Here, RHNSD is activated. That activates mgr check. It checks through the XML RPC API to the Python server if there's anything to do. It's fetched from the database, encapsulated in an XML RPC message, goes back to mgr check. Now mgr check knows there is something to do. And in particular, it's a package installation. Well, if it's a package installation, it needs to go to Zipper, sends a message to Zipper. Zipper turns to the plugin. The plugin tries to fetch the RPM file. It is fetched via the file system, and it goes back to the plugin and back to Zipper. Now Zipper has a file to install, and it will install the file. Let's assume everything goes correctly, and now Zipper has a return result. What will happen is that the return result comes back to mgr check, and mgr check will save the status of the action, which is completed successfully into the database through the same API.
Okay, so here from customer's point of view, I can think of 3 problems, for example, or 3 things to comment on. Is, for example, well, you have Zipper here. You can run Zipper in a system that is managed under SUSE Manager, and it works. But you see here there is a big logic, a lot of components involved. So if you use Zipper directly against the SUSE Manager, this is not the way that the product was thought. So it is not recommended to do it like this. For example, there's a database that won't get updated immediately, etc. And secondly, problems that we usually have with customers about packages not being installed. And first thing I would check is that this stack here, RHNSD, is on the latest version. Sometimes there are problems that are fixed in newer versions, and simply by updating that stack, you can fix a lot of problems. And last but not the least, mind this. It's every 4 hours, randomized. So some customers don't remember or are not aware of that, and they send actions to SUSE Manager, and they want them immediately, and they are not immediate. You have to remember this. You can force the action manually with this command, but it might be not the desired thing. But if you install a traditional client by default, this is the way that is used. And that's why there is another option that Silvio is going to show.
Yeah, I'm going to show it in a moment. Keep in mind that here, where we have the imaginary wall between the client and the server, we have a network in the middle.
Mm-hmm.
And a network can also fail for many reasons.
Mm-hmm.
I think
Yes.
Raul has a nice idea about what are the most frequent problematic cases.
Those are more often during the registration, but in general, you have to set up your network properly. That means all your systems should have an FQDN, a fully qualified domain name, and well, there should be a working DNS, name resolution and reverse name resolution should be possible. And it is important, NTP. So especially for registration, SUSE Manager trusts in certificates, and if NTP is not working properly, those certificates will arise problems, especially during registration. But if your NTP was once set up and it got someone messed with it and it is not running anymore, you might have problems while installing packages.
All right, so in general, if you see that your action is not being picked up, that's how we name it, I would start investigating the client side, so RHNSD logs, zipper logs, the plugin has its own logs. Is RHNSD running? What if I run mgr check manually? Does that work or not? Those are all things that help you troubleshooting. If the client part looks fine, what's in the database? I can inspect it via the UI. Is the action being picked up? Is it already complete? Is it failed? That means that everything has worked, but the package installation has failed for some reason. That's fine. We have to find out what happened at the zipper level. So you might have a feeling now that this gets quite complicated, like this game from the 90s. I know, yeah, it sounds a little bit complicated, but it will get clear in a bit when you start to get familiar with it. So back to seriousness now. One of the limitations of this architecture that we've just shown, Raul mentioned it a while ago, is that we have this 4-hour cycle time. So the trigger for the whole process is RHNSD being fired every 4 hours. And 4 hours might very well be an unacceptable latency time for you. So that's why we have other architectures, and one of them is OSET. You can configure your traditional client to use OSET, and this will change the triggering mechanism in the way I will describe now. So here we have our user creating the action in the database as usual. But now, at this side of the diagram where we are describing the server, we have a process that's much more frequent. It's every 5 seconds. When this is fired, it will fetch the action and trigger mgr check on the client. Let's see how that goes. Here the user is specifying the action. It's saved in the database at some point. Also dispatcher fires, takes the action, sends a message to OSET on the client, and that triggers mgr check. Once mgr check is triggered, everything else continues like before. It's as if you used SSH to get in the client and called mgr check manually. So this is just a triggering mechanism that's different. It's different in the protocol, so you have to open a different firewall port, by the way. And this is a TUT protocol. And we are on purpose using a TUT protocol because that's a low latency way to get a message through. So this is a TUT client, and this is a TUT server. Okay. I am told it is possible to break this too.
Of course, OSAT can be broken, but the biggest issue is that, as I said before, that customer might not be aware of the existence of OSAT and wants something immediate. And by default, traditional clients don't include OSAT. So when you are creating an activation key for registration, there is a tab for adding packages, and you have to add the OSAT package. And then as soon as you add the OSAT package to that activation key, OSAT gets installed during the bootstrapping, and then you have OSAT, and you are using this way of installation of packages and communication in general.
Yeah, just to try to sense a little bit, is there anybody that does not really know what an activation key is, what a bootstrap script is? Everyone is familiar with those concepts? Very good. So, yeah. I have to say, those particular components, JabberD and OZD, have shown some robustness problem in the past when it comes to flaky networks. So if you happen to have a network that loses packets from time to time, or is particularly slow, and the connection is not 100% perfect, we have had some problems in the past. And they could be diagnosed by looking at the logs and seeing, okay, has the message left JabberD? Has the message been received by OZD? And sometimes we had to find and correct bugs because the message was not delivered. And at the end of the day, that means that MGR check is not immediately fired. We have a question. Okay, the question is, does OSAT work with SSH tunnel? And the answer is no. SSH tunnel is a different contact method that I'm unfortunately not going to cover today. But you can reach me at the booth for more information about how that works. I do have slides from a past edition that I could probably show you. The thing is, for traditional clients, we have an alternative triggering mechanism that uses SSH. Which is called SSH push. And architecturally, it looks similar to this. So it's a way to trigger MGR check when something is detected in very high frequency. So at the end of the day, you have low latency. Okay.
What is huge difference between 4 hours and 5 seconds, only for the latency?
There are two answers. So the question is, why is there such a big difference between the two models? One is running very quickly, 5 seconds, and the other one is running very slowly, 4 hours. And the reason is, one of the technical reasons is the position with respect to the wall. If you move that cycle on the client, remember that you're replicating it over many clients. So you would get something that pings the server once every 5 seconds times the number of clients you have. If you have 1,000, 2,000, 10,000 clients, you're going to have a lot of requests to the server, and the server will have a problem in digesting the load. Of course, we could tweak it a little bit higher and say 2 hours and probably nothing will break. But architecturally, we can say it's the wrong solution, or it's a solution that only works below a certain scale. If you scale up, this is not really guaranteed to work well. If you move the cycle in the server you can control the frequency much better. And you can see what happens if the frequency is too high. You just tune it in one place. You don't have to configure 1,000 clients because you notice that the frequency is too high for you, okay? So we actually prefer this model, which is called push, in the sense that from the server point of view, we're pushing data the other way, and not pull, which is the name of the other architecture that I showed you before. And in fact, you will see that in the salt world, this is the preferred shape once again. Okay, so it's mostly for scalability reasons. The other reason why is it exactly 4 hours and not 2 or 3.5 is historical. So this is something we've inherited from the open source project we came from, which in turn inherited it from the closed source project it originated from. So they had a very big initial installation, And 4 hours was already at the limit of what they could do back then. Okay? Of course, it can be changed. That's one line of code. That's not a problem. Okay. Can I continue and make your life more complicated? People laugh, so apparently so. Okay, so one important thing is, so far I've talked about package installation, but actually what we've talked about so far has a lot of commonality with any kind of action, because the triggering mechanism and the way it interacts with the server is the same, whether it is a package installation or a patch application or a package removal or a configuration file change. Is very, very similar, if not identical. And the same machinery also acts in a similar way when we're talking about registration, which is kind of a special case. There are some prerequisites you need to be aware of on the server in order to be able to register a client. You have to have the necessary channels synced to your server. You need to prepare a bootstrap repository. You need to prepare an activation key. You need to prepare a bootstrap script. I guess you're all familiar with those. One catch Raul can probably tell you, and it's about those objects, especially the bootstrap repository and the bootstrap script, can get stale.
Yes, the thing is that the bootstrap repository is generated when you call it manually, and as I said, there was problems with versions. For example, if we fix some bug that prevented registration under certain circumstances, that version is not included in the bootstrap repository. So you have to run the command to recreate the bootstrap repository from time to time. That command is mgr-create-bootstrap-repo. And other than that, not so frequently, but also from time to time, the bootstrap script changes. So it could be that for registration problems, from support, we asked for the bootstrap script, and then we noticed that it was a very old version of the bootstrap script.
So I guess the general recommendation is keep your SUSE Manager server fairly updated, and also regularly upgrade your bootstrap repositories and bootstrap scripts, right? Is that good advice?
Yes, definitely.
Right. What happens during registrations? Basically those things. You run the bootstrap script. What the bootstrap script does is, first of all, it configures certificates and GPG keys. Those are necessary in order to download any package from the SUSE Manager server. It configures the bootstrap repo and installs the packages that are needed on the client, for example, OZ. Then it runs this particular script, rhnreg.ks, which will send to the server inventory information using the same channel that we've seen before, apply any activation key. If the activation key specified packages, install them, configuration files, change them, and ultimately call mgr check, which will do the usual things. As a last step, it will also install and configure this particular package, which is part of the client tools. Note that corresponding to some of those points, something also happens on the server side. When you configure the bootstrap repo, the server is going to serve it through Apache HTTPD. When rhnreg.ks is run, it will save hardware and software inventory data in the database through the Python API. It will react to activation keys. It will react to mgr check calls. And ultimately, what will happen is that the errata cache for that client is refreshed. Now, the errata cache is the piece of information inside of the database that says server A can get patch B from channel C. So it's the bit of information in the SUSE Manager server database that says which patch is applicable from which channel to which server. This is very central to most of the functionality that we have. And this is something that happens once everything else in the registration is already finished. Not sure if you want to add something,
No, mainly, as I said, most problems with registrations are either outdated bootstrap script, and that means outdated versions of the stack, or network problems, as I said before, so NTP, DNS, such things. So those are the things that are more important to remember.
Okay, time to talk about salt minions. Can I get your life more complicated? We're still going through the same use cases, package installation and registration. Let's start with package installation. Here we have an architecture which looks similar to OZ. We have a process that runs pretty frequently checking for actions. And when they are ready, the action is turned into a salt command. This is the critical part. It's translated to a command that goes to the salt API and goes to the salt master. Now, is anybody in the room not very familiar with the salt-specific concepts like the master and minion and API? Someone, yeah. So salt has server-side and client-side components. The server side is called salt master. The client side is called salt minion. Here we have our wall. The communication channel is different. It goes through two TCP ports. One of them is number 4505, shown here. Basically, what you can do with a salt master is you can send a command to many minions. You can ask the salt master, please run this. It's called a module, piece of code, basically, on this subset of my minions. And you can specify the subset in various ways. And what the master will guarantee is that this message is transferred to the minions, and the minions will try to apply it. When they finish, they will send back an event. So this is just the first part of the process where the message goes to the minion. So we can see a simulation. No, before I get to the simulation, I will complicate things a little bit more. And I'm adding one component down here. So once the message goes to the salt minion, it's a package installation, so it will invoke a package manager. Could be zipper, could be yum, could be DNF, could be APTs if you're using Ubuntu. And the package manager will need to fetch the package. And will fetch it this time through Tomcat and not through the Python API. OK, let's see how this works. User schedule an action, goes to the database, as usual. Then at some point, yeah, Aspermatic fires. It's actually much faster than that. It will grab the action, translate it to a salt command, send it to the salt master. The salt master will send it to the salt minion, and the minion will ultimately send it to the package manager. What does the package manager do? It will install the package, but in order to install it, it needs to fetch the package. So what it will do, ask via HTTP the package. The package comes from the file system. Note that the information here is merged with some information coming from the database. The reason for this is that we want to make sure that only some minions have access to some packages. What you do is to assign minions particular channels. This means that some minions have the right to access some packages, but not others. How do we enforce that only cleared minions can access the package? We do that through a token. If you ever opened a repo file for a minion, you will notice a very long string in it. That's a token. It's a security cryptographic measure that's checked in here against the database to make sure that the minion can download that package. And if it can, then the package goes to the package manager. And the package manager can install the package. What next? Let's complicate the picture. This is what happens on the way back. The package manager will inform salt minion that it's done. The salt minion will inform the salt master, and the salt master will inform the MGR event salt engine. Now this might be a little bit too fast, I'm sorry. Anyways, this is again the barrier between the minion and the server. Salt master gets the event. Package manager is finished. It passes it to a special component that's internal to SUSE Manager. It's called the salt engine, and this will write the event into the database and also notify Tomcat. Tomcat will then digest the event. For example, if the package has been installed, it will update the database saying, okay, package version for this minion went from 1 to 2 through a number of worker threads that's configurable, so that this component is able to handle a lot of load. This is the problem here, because if you have many minions, you could have many results coming at once, and we want to scale this through a number of workers. And ultimately, the return result is saved into the Postgres database. Now, Rahul, break it. Tell me how it breaks.
Yes, usually what customers would complain about is I'm installing a package and it doesn't get installed or nothing happens. What's going on? So the first thing to check, now you have a quite big new component that is salt. So the first thing I would check is salt logs. And those are easy to remember because they are in the same path in the client and in the server, and it's in var log salt. You have master and API files in the salt master, that is the SUSE Manager, and you have in the same path a file called minion in the minion, and those be the files for starting the debugging.
It might happen that the action is actually executed correctly on the minion, but you don't see it from the UI. If you check in the minion, the package is really installed, but the UI doesn't reflect that. If this happens, what I would start looking at is this component, the MGR events component that's supposed to dispatch the event to Tomcat in order to be saved into the database. So by the way, this is a new component that's been introduced only a few weeks ago in Manager 3.2.6. So this picture is really fresh. What happens when I register a salt minion? Well, actually, it's not that different. The core things that need to be done in order for a minion to be registered, not that different from a high-level perspective, at least, to what happens on a traditional client. What is a little bit different is that you have more than one method to register a minion. So first of all, the bootstrap script is optional. You can still register a minion to a server via bootstrap script.
Yes.
That's pretty similar.
As a reminder regarding the bootstrap script, since the last versions, when you generate a bootstrap script, by default it is a salt bootstrap script. So remember this, in case you want to use traditional, you have to use a parameter to tell the command that generates the bootstrap script that you want a traditional bootstrap script. And you can also generate the bootstrap script from the web UI, and then you have a check in which you can select traditional or salt.
If you don't want to use a bootstrap script, you can onboard a new minion directly from the UI. Or you can manually install salt minion and accept its key on the master. And those three ways all lead to the same end result.
Okay. Yes?
We have a question.
The manual method through the UI, is that leveraging salt SSH in a way?
Yeah, the question was, does the UI method leverage salt SSH under the hood? Yes, it does. I will get to that in a moment.
Okay. And also remember that if you use a bootstrap script, you have to accept the key. For the third method, with installing salt minion manually as well, it is written there, but for the web UI, the key gets accepted automatically.
So one of the concepts that's in the salt world that's not really present in traditional world is that it's not sufficient to have the client tools installed in order for the minion to be registered. There's also an extra step which is called key acceptance. This is a cryptographic measure to make sure that the minion that's trying to connect to the SUSE Manager server is really the minion that It has to be. So there's no man in the middle. So by default in salt environments, you always have to explicitly manually accept the key of the minion in order for it to be registered to the salt master. And this is also true in SUSE Manager. There are configuration parameters to avoid that if you don't mind about the security aspect. Okay, so this is what happens if you use a bootstrap script. Well, it's pretty similar to what happened before. The bootstrap script will configure certificates and GPG keys. Why? Because it has to configure the bootstrap repo. Why? Because it has to install at least the salt minion package. No other packages are required, but salt minion is. So you have to get it somewhere, and that somewhere is the bootstrap repo, happens to be protected via certificates and GPG keys, so that's the first thing that you have to configure. Once salt minion is installed, there is a few configuration parameters that need to be changed, in particular minion ID and master. Those are the essential ones. There are others. The bootstrap script takes care of those and starts the salt minion process. What happens on the server side? Well, the bootstrap repo is served, and at the end of the process, when the salt minion is started, it will immediately contact the master, and then on the master, its key is displayed, and you have to accept it. If you accept it, everything continues, and the registration, basically continues and finishes. So this is instead what happens if you use the UI. As somebody noticed, the UI registration method actually is triggered from the server. And the first thing that the server will do is to apply a state, a salt state, to the minion via salt SSH. This means that the server will contact the minion via SSH, copy over all the salt machinery, copy over this particular bootstrap state, and apply it. What will the state do? Basically the same thing that the bootstrap script does. So it will configure certificates, GPG keys, bootstrap repo, install the salt minion, set the minimal variables, and start the salt minion. It's the exact same set of operations that happen. Okay. Then the third method is to manually install salt minion. So in this case, we just assume salt minion is installed some way. So it's up to you how you serve the package, how you install it, if you want certificates or not. At the end of the day, what we care about, there is a salt minion daemon. It's running. It has the right configuration parameters, at least those two vital ones. And at this point, you will see the key in the SUSE Manager UI or command line. You accept it, and registration continues. In all those three cases, what will happen next is the following steps. So once the key is accepted, the minion is completely usable with pure salt. Everything else is something else that SUSE Manager does on top. The remaining steps are to fetch the inventory of the hardware and the software and store it in the database, and apply the activation key. So if the activation key, again, has any packages or configuration files or salt state, will be applied, and refresh the errata cache, which is what happened before as a last step also in the traditional world. Those 2 points are once again implemented via salt state. We do everything with salt state these days, so that should come as no surprise. Okay, so of course, if you have any trouble with this process, the starting point is the logs, and in particular, I would say in this case, the minion logs, or the output of the bootstrap script directly, if that's what you're using.
Yes.
Okay, last point in this presentation. How does CVE audit work? CVE audit is a feature in SUSE Manager that allows you to check which of your minions or traditional clients equivalently may or may not be affected by a certain CVE number. The outcomes might be 4.
Yes.
Do you want to list them?
Yes. So in the web UI, when you are looking for a CVE, for example, you remember 2014 shell shock, for example, you type the number of the CVE, you look it up, and it will show all your minions, and you will have 4 possibilities. So either you will get that the system is patched, and then the vulnerability was fixed. The system is not affected at all, maybe because it was a service pack that was published later on. But if the system is affected, there could be 2 possibilities. One of them being that a patch is available in a channel that is associated to this client, so you simply need to install the patch. Or it could also be that there are no channel assigned to this client, and you need to look for one channel that has the patch. For example, if you are using clone channels, do you know what clone channels are? Okay, so if you are using clone channels, maybe you don't have the patches in those clone channels, and you would need to merge the patches into those clone channels. And those are the 4 possibilities.
Okay, how is that implemented? Well, of course, users interact via the UI, and what they are actually shown comes straight from the database, which has information about the minions and the clients, and what packages are installed, what updates are available, what CVE numbers affect those clients. And the database is fed by several processes. So salt minions will send data to Tomcat basically in the servlets, and this will end up in the database, like this package has been updated to this version. Traditional clients follow a similar path, but through a different component. And also the database knows everything about the repositories that are served to the clients and the minions. This comes from the reposync process. So at the end of the day, the database has a condensed view of all these data streams. It will serve it via the UI. There is an important detail, that's this box over here. And the detail is the following. In order to keep the UI fast enough, because the data that's involved here might be very large and the number of combinations might explode, we have a caching mechanism that will pre-compute some of the CVE audit data. And by default, this runs every night. So in the UI, if you use the CVE audit feature, you might have data that's as old as the last run of this process. So you might see data that's 24 hours away, worst case, from what you're seeing. So in case you want to have the very latest data, you can run this manually through the UI. And once it's finished, you're sure to see the very latest information. Okay. So we are done with our presentation. So if you have any questions, they're still very welcome. Also feedback. Remember about submitting feedback from SUSECON in general. And if you like this presentation, let us know.
Yeah.